For example 5.31, given fx equal to 2 plus ln x plus 1, sketch the graph of fx and f inverse on the same x. And state the domain and range of fx and f inverse. For this question, we should not find its inverse. That only reflect the fx to get the f inverse. To sketch the graph ln fx equal to 2 plus ln x plus 1 by using the basic properties. Step 1. When fx equal to 0, 2 plus ln x plus 1 equal to 0, ln x plus 1 equal to negative 2, x plus 1 equal to exponent negative 2, and x equal to exponent negative 2 minus 1. By using calculator, the value is negative 0.9. Next, for the second step, find the vertical asymptote. For this function, ln x plus 1, that means x plus 1 must be greater than 0. X plus 1 equal to 0, x equal to negative 1. That means x must be greater than negative 1 for this function. When x approaches to negative 1, the graph approaches to vertical asymptote. Fx approaches to 2 plus ln 0.000001. That means 2 plus negative infinity. 2 approaches to negative infinity. Therefore, when x approaches to negative 1, fx approaches to negative infinity. And the third step, when x approaches to infinity, fx approaches to 2 plus ln infinity. 2 plus infinity. Therefore, when x approaches to infinity, fx approaches to positive infinity. To sketch the graph fx and the f inverse, first draw the dotted line y equal to x. And the second, draw the straight line and call vertical asymptote when x equal to negative 1. X equal to negative 1. Now, when y equal to 0, x equal to negative 0.9. And when x approaches to negative 1, y approaches to negative infinity. And when x approaches to infinity, fx approaches to positive infinity. And label the graph is fx. We can sketch graph f inverse reflect from the graph fx. When fx have vertical asymptote, the inverse is horizontal asymptote at y equal to negative 1. When intercept x-axis at negative 0.9, the inverse is intercept y-axis at negative 0.9. And the graph is approaches to horizontal asymptote at negative 1. And when x approaches to infinity, fx approaches to positive infinity. And here is the graph f inverse. Now, state the domain and range of fx and f inverse. Domain of the function is equal to the range of the f inverse. We refer the value of x greater than -1. So, from -1 to infinity. And the range of the function is equal to the domain of f inverse. From -infinity to infinity. For example 5.32, given fx equal to 2 the power 2x plus 3. That is called the exponential function. The question is, sketch the graph of f and f inverse on the same x and determine the domain and range of fx and f inverse. To sketch the graph exponential by using basic properties. First, fx must be greater than 3. Refer the function. And for x element of a real number. That means the horizontal asymptote for this graph is y equal to 3. And find the intercept y-axis. When x equal to 0, fx or f0 equal to 2 power 0 plus 3. 2 power 0 is 1, 1 plus 3 equal to 4. And third, when x approaches to infinity, fx, the function is to be greater and greater. Fx approaches to infinity. For the fourth step, when x approaches to negative infinity, that means fx is approaches to 2 power negative infinity plus 3. 2 power negative infinity is approaches to 0. 0 plus 3. Next, we try to sketch the graph exponential. First, number 1, the graph have horizontal asymptote y equal to 3. Y equal to 3 and the graph is intercept y-axis at 4. And when x approaches to infinity, fx is approaches to infinity. To the right and increase. When x approaches to negative infinity, to the left, fx is approaches to horizontal asymptote at 3. Approaches to 3 and label fx. Now we can try to sketch the f inverse. Sketch the vertical asymptote x equal to 3 and intercept x-axis at 4. And the graph inverse is approaches vertical asymptote at 3. And reflect the graph f inverse. And label f inverse x. For question B, Determine the domain and range of f(x) and f inverse. The domain of the function is equal to the range of f inverse. The domain of the function is negative infinity to infinity for exponential function, and the range of the function is equal to the domain of f inverse. Refer number 1. f(x) must be greater than 3. Therefore, range of the function is from 3 to infinity, not including the 3. For example 5.33, the functions f and g are given by f(x) equal to 3 plus exponent 3x and gx equal to ln x minus 3 to the power of 1 over 3. The function f(x) is exponential function, and the function of g is logarithmic function. The question is, show that f and g are inverse each other. Hence, sketch the graph of f and g on the same x. How to show that f and g are inverse of each other? We can use the concept f composite f inverse equal to x. For this question, find the f composite gx, and to show that equal to x, refer from the function f 3 plus exponent 3 and the input is gx, and 3 plus exponent 3 and the function gx is ln x minus 3 to the power of 1 over 3 equal to 3 plus exponent using the power rule, exponent ln x minus 3, and the concept exponent ln x equal to x. Therefore, 3 plus x minus 3 equal to 3 minus 3 plus x equal to x. Next, the concept is g composite g inverse equal to x. Now, find the g composite fx to show that f is inverse for g. Refer from the function g ln and the input is fx minus 3 to the power of 1 over 3. Ln the function of fx is 3 plus exponent 3x minus 3 to the power of 1 over 3. By using the power rule, 1 over 3 ln 3 minus 3 is 0, therefore ln exponent 3x. And the second time, by using the power rule, 1 over 3 times 3x ln exponent. 1 over 3 times 3x is x, and ln exponent is 1 equal to x. Now, shown f and g are inverse of each other. For the next question, hence, sketch the graph f and g on the same x. Hence, that means f and g are inverse of each other. We can sketch the graph f and reflect to find the graph g. By using basic properties, to sketch the graph exponential, First, fx must be greater than 3 for x element of real number. Why fx must be greater than 3? Because fx equal to 3 plus exponent 3x. When x approaches to negative infinity, the value of exponent 3x is nearest to the 0. And that means fx approaches to 3. And the second, find the intercept y-axis. When x equal to 0, f0 equal to 3 plus exponent 0. 3 plus exponent 0 is 1, equal to 4. And the third, when x approaches to infinity, to the right, fx approaches to 3 plus exponent infinity. Exponent infinity is the largest value. So, fx approaches to infinity. And the fourth, when x approaches to negative infinity, fx approaches to 3. Now, we can sketch the graph exponent. To sketch the graph exponential, first sketch the horizontal asymptote. Y equal to 3. And the graph intercept y-axis at 4. By using basic properties, when x approaches to infinity, to the right, fx approaches to infinity, increasing. And when x approaches to negative infinity, to the left, fx approaches to 3. Approaches to horizontal asymptote, but not touch the horizontal asymptote. Next, how to sketch the graph G? We reflect at y equal to x. When fx has horizontal asymptote, gx have vertical asymptote. X equal to 3. And intercept x-axis at 4. When fx approaches to horizontal asymptote, gx approaches to vertical asymptote. Not touch the vertical asymptote. And we can reflect the graph G. And the smooth graph gx. Okay, done. For the final of lecture 5, given this exercise, the function f and g are defined as follows: fx equal to 4 minus x squared and gx equal to exponent 1 over 2x. Determine whether f is one-to-one function. You can use the algebraic approach or sketch the graph. And give reason for your answers. And question B, find G inverse and state the domain. And question C, obtain the composite function G inverse composite fx. Try your best and good luck forever. Thank you.